I should have done that already. Let's keep going. So this is something that we haven't done in a while, but I just wanted to keep this in mind. You should really be familiar with a lot of the vocabulary, okay? You can kind of write this down anywhere, but where are products again? We're thinking about where are products and where are reactants. Are products on the left or the right? Products are on the right. Yeah, so products are like what goes in, like if you're baking at the end, you put your ingredients in, you put it in the oven, at the end you get a cake, right? That's your product. Your reactants are on the left side. That's what's going into your cake. So like if you have an equation and it's like, let's see, right? Here we go. So let's just say this is your sample equation. It's like A plus B yields AB. Your product is AB. Okay? Your reactant would be A plus B. How about coefficients? What's a coefficient? The big one. So if you have something that's like, whoa, I don't know what that, ignore that. Okay, I was going to make this like an X. I still can. There we go. So a coefficient would be like a big number in the front of a symbol. That's a coefficient. Coefficients go to everything. Subscripts, on the other hand, subscripts are like the little one. They don't go to everything, okay? They're different. So be clear in your vocabulary for these things. It's very, very important that we get that going on. All right. Next. Retaking the Unit 4 exam, really, if you haven't already started that process, if you did not do well, really, if I can maybe extend it until, I would say, when am I going to see y'all? I'm going to see y'all on Monday. But you've got to get that taken care of if you haven't talked to me about that already. Okay. All right. We're not doing this. Okay. So now we're going to get into what we're doing for today. And that is, we're going to be, Natalie's still with us. Okay. We're going to be talking about predicting product synthesis, decomposition, and combustion. So, are we all in our notes? Do you see where we're at? Day 3? It's going to be pretty... Oh, actually, we're going to...
Hello.
Predicting part. We're going to go straight... Oh, yeah, there we are. Yeah, here we are. Does everyone see where we are in the notes? Should be like page 5 in your notes. Page 5 in your notes. Where it says day 3? Next one outside. There we go. This is our last, oh my gosh, everybody, this is our last lesson of the whole like semester of the whole 2020 year. After this is going to be reviewing and tests.
I'll keep my ears and eyes open.
Okay, so does everyone see where we're at? Find it in the notes? Yeah. All right. So with this, any reaction we see, if you see this, and we asked this in the warm-up, I said, what are the products of combustion? And not everybody knew right away. These are always the products of combustion every single time, no matter what. I promise you, you will see this on your test, okay? That is always the products of combustion every single time. Carbon dioxide and water every single time, no matter what. You will see this on your test. Put a star on it. It's always going to be carbon dioxide and water. And guess what? This is always going to be at the beginning. Okay? This is on page 5 in the notes packet. So if you see carbon dioxide and water, you should be thinking combustion. this thing at the beginning, this C with the numbers underneath it, that's called a hydrocarbon. So you're always going to see the hydrocarbon plus the oxygen on the reactant side. You're always going to see carbon dioxide and water on the product side. That is what a combustion reaction is by definition. It will look like that every single time. Okay? Every single time. So for those of y'all who've been out, I know some of y'all have been out for a couple of classes, please make sure you look over the different types of reactions because we're not going to go over all of them today. Today we're focusing on combustion because you have to balance these a little bit differently.
Yep.
Okay, so combustion balancing is a little bit tricky. I'm gonna
Suffer.
yes.
You can just keep that right there. I'm gonna take some notes.
You're gonna take the notes?
Yes.
Okay. You may hang on a second. We'll give them a minute. So we balance these combustion reactions differently than we balance the other types. Okay. All right, so these I'm going to explain like step by step how to balance these. These are different from the other types where it didn't really matter what order you went in. These ones actually matters quite a bit the order in which you balance. So I call it CHO order, CHO order. You always start with the carbons and then you go from there, okay? You have to start with the carbons though. Always, 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 always start with the carbons. So let's do it. CHO order, CHO order.
I wasn't finished writing notes.
I think it was just a couple blanks. We're finished. Couple.
Thank you.
There we go.
Carbon.
Got it?
Not yet, not yet, not yet.
Okay, not yet. Ready?
No. Sorry if I'm holding you up. Really have to actually pay attention and focus. Like focus like a hawk, like a hawk.
Okay, let's see.
I'm almost done. Almost. Almost there.
And there's a hard copy too on Canvas, just in case. Like if you miss something, I'll also put the hard copy up there.
Okay, hard copy. Thank you very much. Okay, you can go ahead now.
Okay, so we're gonna go ahead. I'm gonna start balancing. We're gonna balance in CHO order, CHO order, CHO order. So it sounds ridiculous, but that's what we do. Remember how on the other ones I said it didn't really matter what order you went in, you could start with whatever you wanted. Remember that? I was like, it doesn't matter. On these ones, it does matter. So for combustion, in particular, combustion only, it really, really matters where you start. You have to start with the carbons, okay? As always, we're going to treat the arrow like an equal sign. I need a different color, I think. Okay. And maybe yellow. There we go. Treat the arrow like an equal sign. Okay. And then we're going to start with our carbons. So on the left side, how many carbons do we have? How about on the right side? Are those the same number? No, they're not the same number. So I'm going to change that to a 2. So CHO order. So what do we have to do? If we balance our C's now, what do we have to do? Balance the H's. Okay, so on the left side, we've got how many? How many are over here? 6. How many do we have over here? 2. Are 2 and 6 the same number? Are they? No, they're not the same number. So what do I need to put? Should I just change this subscript? Can I do that? Can I just cross off that subscript and make it something different? Can you change subscripts? No, we can't change subscripts. So we're going to put a coefficient in the front. Why are you doing this to me? I'm going to put a coefficient of, stay, 10. I'm going to put a coefficient of 3. Right? So 3 times 2 is equal to what? 6. So see, now our H's are at 6. So now what do we have to do? Well, let's check. We got to do our O's, right? Now, this is where combustion are really different from all the other types of reactions. And that's why it's so important to balance them in CHO order, because you got to pay really close attention. Okay. We've got 2 over here. But how many do we have on this side? Let's count and be careful when you're counting. What do you think? Yes. Okay, so we've got 2 times 2. What is 2 times 2? 4. But look, do we have more oxygens? There's some more over here. So we've got 4 plus 3 more. Okay, so how many oxygens do we have in total? 7. Okay, so that's a little bit of a predicament because I have 2 over here. What am I going to do? I can't say, well, maybe I'll just put a 3.5 in front of there. Can you have 3.5 of anything? Can you have 3.5 molecules? No. So here's how you fix it. Okay, I am going to put that 1 in the front, but all you have to do is just double it. That's right. So I'm going to put a 7 here, and then I'm going to double all these other numbers. And I promise you, if you just double everything else, it makes it work out. So what do I mean by double it? And these end up looking kind of messy, right? Because you're going to have to cross things out. But if you count again, and if you look at our totals, you're going to see that, in fact, now it is all balanced. So now on the left side, we have 14 oxygen. On the right side, we have 4 times 2 is 8, right? Plus 6. What does that equal? What's 8 plus 6? 14. So actually, it is now balanced. Okay? So these ones are ones where you may find it. Remember how we were talking about some people like the table and some people really don't? In this case, it might be helpful for you to see the table just at the end, right? So I'll put those notes down. So I've got 4 carbons on the left. I've got 4 carbons on the right. I've got 12 hydrogens on the left side. I've got 12 hydrogens on the right side. And now I have 14 oxygens on both sides. So I'm following the laws of conservation of mass. It's a little bit tricky, okay? I know that, but I think you can do it. So just be patient and careful with these these combustion reactions. It's not always this difficult. And I think the next example is a little bit easier because you don't have to double everything. Okay, let's try another one. Ready? Ready. Okay. Once again, we're going to go in CHO order. So where should I start? I'm going to start with the carbon. Very good. Yep. I'm going to start with the carbon. So how many carbons do I have on the left side of this reaction? How many do I have on the right side? Just one. Are 3 and 1 the same number? No. So what should I do? What do I do? Put a 3. Very good. So now I'm at 3 and 3. I'm going to go in CHO order. So now what do I want to balance? The H's. On the left side, how many do I have? 8. How about how many do I have on the right? 2. Is 8 the same number as 2? No, that's right. That's not the same number. Okay, so I'm going to put, what do I put?
A 20.
A what?
Like a 20.
A 20. That's a lot. That's too many, I think. What do you think for real?
Oh my goodness.
A 4. What's 4 times 2? 8. Yeah, so look, now my hydrogens are balanced. Okay, so I'm going to put a 1 there. And now let's look at my oxygens. How many do I have on the left side?
Yeah.
I got 2 over here. Remember, you have to be careful because look, oxygen is always going to be in 2 places on these types of problems. So what is 3 times 2? So I've got 6 plus 4 times 1, 6 plus 4. So how many do I have? 10. And on this one, it's nice because I don't have to do the weird doubling thing because how can I make this oxygen 10? This one over. Yeah, I'm going to put a 5 over there. Okay, so you don't always have to do that weird doubling thing. It's only if you get into a situation like a number 7, right? Or a number 15, something like that. You're going to have to do the doubling. That makes sense? I know it's a little bit tricky. Are we all okay?
Not yet.
Not yet. Okay. Sometimes it's just different to do it live. All right, so gotta wake up.
We about to text coach to the virus.
All right. All right. We're gonna go to the next problem. Here we go. Where do I start? Do I start with oxygen? Do I start with oxygen? No.
Definitely not.
The carbon. That's right. We have to go in CHO order. So this carbon on the left side, how many do I have? 4. How about on this side?
4. Not 8. Not 8.
What are you talking about?
2.
2. It's 1. Can you see?
I said a 2.
Oh my God.
The 2 goes with that oxygen. I need to put a 4. All right. Let's look at our hydrogens. How many do I have on the left side?
Oh, you got that 2.
You have 6. For the little guy, you got 6.
6. We got 6. How many do we have over on the right side? On,
Well, 1, but you have
that's right. So you are a step ahead of me. We've got 2 over here, and you're right. We need to make it a 3 because what is 3 times 2? 3 times 2 is 6. Very good. Go back to pen. 3.
You're thinking of that 2 times 3.
2 times 3 is 6. That's right. So if we're keeping track, okay, I'm going to draw them out. Our C's, we're at 4 and 4. Our H's, we're at 6 and 6. Whoops. Nope, not that. Now we have to do our oxygens. Always do your oxygens last. If you don't, you're not going to end up with the right totals, I promise. So over here, we've got 2. Now let's count how many are on the right side. What is 4 times 2?
8.
We got 8. Is that it? Do I have some more oxygens?
No.
Are you sure? I think you need to look harder. We got 3 more. So what's 8 plus 3? 11. Oops. So this is going to be one of those that's a problem, right? Because what's half of 11?
There is no half.
There's no half of 11, right? It would be 7.5. And can you have 7.5 oxygens? No, you can't.
Try hard enough.
You can
Can't
try.
have a
It's not
7.
gonna work.
It's an odd number.
Yeah. So we're gonna solve that by just putting the 11 here and doubling everything else. Okay. So I'm gonna change this to a 2. I'm gonna change this one to an 8.
Only when you half.
And I'm gonna change this to a 6.
You.
And now if you count, everything is gonna be balanced perfectly correctly. So if you updated your totals, it's gonna be correct now, because now I have 8 carbons on each side. I've got 12 hydrogens on each side. And I've got 22 oxygens on each side. And it's balanced. So don't panic if you end up in a situation with a number like 11 or 7. Don't panic. Take your time. Just be like, just double everything else. It's okay. Does that make sense? These are a lot harder, but these aren't going to be the majority of your test. Okay, they are harder, but they're not impossible. They take a little more time. They're not the kind that you can do guess and check on. I'm going to be honest. Remember how with every other type, I think the guess and check method is way easier and faster. This type, I think, really kind of does require writing down a table. The rest of them, no. But most of the reactions aren't combustion reactions. I had to teach you for the few that you're going to see. Okay, let's practice one more.
Yeah.
Okay, so on this one, I've been telling you, you have to know the products for combustion because they're the same every single time. We talked about it in our warm-up. So what is it? What is it? CO2 and H2O, very good. CO2 and H2O. And I promise you this will appear somewhere on your exam. I promise you. Whoop, that's an O. It's just kind of ugly. Okay, so we always solve them in the same order. What is that order? Cho order. So I'm going to start with my carbons. Let's count them out. On the left side, I have 5. How many do I have on the right? Well, I have none right now, or 1 right now, right? As usual, Gabby, you're 1 step ahead of me because I knew what you meant. You knew there needed to be a 5 right there, right? Why do you keep disappearing, Pen? Okay. So. Yeah, so that's supposed to be a 5. 5. All right, so now let's do our H order. What's next? We got 12 over here. How many do we have over here? What do you need to
7.
do to make it 12? 6. Good job.
I was close. It was 6, not 7.
Who's taking pictures for basketball? All right. All right, y'all. Up here. Continue. Now, let's do our oxygens. Our problem child is always the oxygens. They're always the most complicated. How many do we have on the left side? How many do we have?
Oh,
We got 2. Now we're going to count my oxygens on the right. Okay, what's 5 times 2?
like 10.
It's 10. Plus, whoop. What's 10 plus 6? What does that equal?
16.
16. Oh, phew. This is one where I can balance it way more easily, right? Do I have to double anything? Okay, so I just need to think what times 2 is equal to 16?
8.
8. And unbalanced. So not every combustion reaction is really, really difficult. Right? And once you know the method, CHO order, none of them are too bad. Is that making sense? We're good? All right. Okay, so now we're going to switch gears a little bit. And we're going to talk about oxidation reduction reactions. REDOX. REDOX reactions. Okay, so in an oxidation reduction reaction, these are also known as redox reactions. This is a specialized type of reaction. I'm going to be honest with you, these are actually a lot more complicated, but if you want to know more, you can go on to chemistry, AP chemistry, or in college chemistry. You're going to go in tons of detail about these redox reactions. We're just going to give you the very most basic, simple version of redox reactions, which is good. Like, these are going to be easy because we all know. I'm gonna remind you all of my little memory tricks that you're probably sick of hearing about. Oh, okay. Okay, so oxidation reduction reaction. Your little blank is the word redox. So what you're filling in on your notes is this one here, that redox part. Redox. Okay, so in an oxidation reduction reactions, your next blank is electrons. Okay, the next blank that you're supposed to fill out is the word electrons. Electrons move between atoms. Does this sound like something we've learned about already? What happened in an ionic bond? What happened to the electrons? You don't know. Why do they have those plus and minus charges? What happened? Their electrons moved, right? So remember we talked about this? We talked about how cats lose lives. Remember that? I know y'all remember cats lose lives, right? So the metals are losing their electrons, and what's gaining the electrons? The nonmetals. See, remember. Okay, so in a redox reaction, reduction in the most simple terms is gaining electrons. And in the most simple terms, we want to associate this, and you should write this in there where it says gaining of electrons. That's going to be metals. I will write that in there if I was you. I'm going to change this color again. What color are you? Pin? If I could, there we go. Back to red. Okay, so gain, I want you to write reduction. What you need to know about that, that's going to be happening with who's gaining, metals or non-metals. What do we say about non-metals? Onions have layers, right? Remember that? So that's going to be your non-metals. Reduction happens to your non-metals. Oxidation happens to your metals because that's a loss of electrons. Okay, that's what you really need to learn. Remember, we said cats lose lives, metals go meow. So oxidation happens to metals, reduction happens to your non-metals. And like I said, don't come back to me once you've gone to college and you learn that this is actually a little bit more complicated than that. This is all you need to know. For you, here in your first beginning chemistry course, as far as you need to know, reduction is going to happen to your non-metals, oxidation is going to happen to your metals. So just keep those terms in mind. There is a memory trick for this. Okay, and that is oil rig, and I'm going to tell you that on the next blank. So, oh yeah, I think, yeah. So in oxidation reduction reactions, these are always paired together. Oxidation does not happen without reduction. So if we think about that, that's like basically what this, what an ionic bond is, right? So this on your next page. We're all on the back page. We're almost done. So electrons that are lost by the reactant that is oxidized and gained by the reactant that is reduced. So who's gaining? What? Can't see. Oh, it's black. Why is this? You're right. Let me. I don't know why this is purple. Okay. Whoa, where'd it go? There we go. I gotta move this for a second. I'm gonna make that. There we go. Now we can see it, right? There we go. Okay. Hang on. There. There. Why are you doing this to me over here? Okay. Now we can all see. Okay. Can you see that? So oxidation reactions are paired with reductions, and electrons are lost by reactants that are oxidized, gained by those that are reduced. Okay. Did I go too fast? We okay? You good? Okay. Okay, so how do you remember this? I remember the little trick, oil rig. Oil stands for oxidation is losing. Oxidation is losing. Oxidation is losing. Oxidation is losing electrons. This happens to your cations or your metals, okay? Metals. Metals go meow. Metals. Anions, these are non-metals. Whoop. That's your non-metals. And it would help if I could write. Okay, so in an oxidation reaction, once you lose electrons, you're more positive. You have more protons. That makes sense, right? If you get rid of electrons, you have more protons. That's going to give you a positive charge. In reduction, you're going to become more negatively charged because what are you gaining? You're gaining electrons. Okay, so that makes sense. All right. We're almost done. Okay. Let's keep going. We're almost done. I want to even watch this. Okay. So in this little, your next blanks, see here, sodium is oxidized. That's what you're putting in that blank. Sodium is oxidized, and it's oxidized because it's losing an electron. That's because metals, cats lose lives, right? Metals go meow. Cats lose lives. So sodium's a metal. That's why it's going to lose an electron and get oxidized. So if you can just remember that oxidation happens to metals, it's going to be easy. Chlorine is getting reduced. Chlorine is a nonmetal, and it's going to gain an electron. Remember we said the nonmetals make those anions. Onions have layers. That's our gaining. We're almost done. So in the, we all got that? We're good? Oh, in your little boxes, I guess you have those little blank boxes. You can write Na yields. Once it loses an electron, the little half equation will look like this. A little plus sign because it's lost an electron and now it's positive plus a little electron. Oh, it is already written for you. Okay, then we'll keep going. Okay, so in our redox reactions, here's another example. Mg plus S. What type of reaction is this? Can we think about what kind of synthesis? Very good. That's a synthesis reaction. It's also a redox reaction. So they can be both. So in this synthesis reaction, which one's the metal? Magnesium or sulfur? Magnesium. So which one is, what did we say happens with metals? Are they oxidized or reduced? Oxidized. So which one's oxidized? Magnesium. See, it's as easy as that. So is this one already written for y'all too? I'll write it in. Here we go. So this is what happens with our oxidation. You've got Mg, and it will yield Mg with a positive charge, a positive plus. Oops. That's supposed to be a 2. Positive 2 and 2 minus 2e, 2 minus electron. So which one's getting reduced? Okay, if magnesium is getting oxidized, which one? It's the sulfur. So there you're going to end up with sulfur S plus a negative 2e. Very good. These are called half reactions. Okay, they're half reactions. And we got one few more for practice problems. Again, if you can remember that oxidation goes with metals and reduction goes with nonmetals, you're going to get these right every single time. Oxidation goes with metals, reduction goes with nonmetals. That's all you have to remember. Okay. Actually, I think we took the oxidation, we took this out of your notes, that agents. So you don't need to worry about that. We took this out of your notes this year. Okay, so let's just do a little bit of practice. Once again, if you can remember that oxidation happens to the metals and reduction happens to the nonmetals, which one here is being reduced?
What happens to the metals again?
Metals get oxidized.
Got it.
Metals get oxidized and nonmetals get reduced. So which one's a nonmetal? Chlorine. So which one's getting reduced? It's the chlorine. Yeah, that's our chlorine. What? Why did you keep doing this to me? Okay, once again, metals get oxidized, non-metals get reduced. Which one's the metal? In potassium and fluorine. Which one's a metal? Potassium. So potassium is the one getting oxidized. Potassium. Okay. Once again, metals get oxidized, non-metals get reduced. So which one's the non-metal? Strontium or nitrogen? Nitrogen.
Ooh, I think it's nitrogen.
It is nitrogen.
Yeah, it was nitrogen. Okay.
Nitrogen.
Nitrogen is a non-metal.
Okay. Then we have one more. Okay, So what happens, we're asking about sodium. Is sodium a metal or a non-metal?
It's a metal.
It's a metal, so is it getting oxidized or reduced?
Oxidized.
Oxidized. See how easy? Metals get oxidized and non-metals get reduced.
Got it.
Yep. You can
Metals
remember that, then
oxidized.
you've got
Non-metals
oxidation, everything
reduced.
you need to know about oxidation reduction for this class. It is more complicated out in the real world, but that's all y'all need to know. Okay? All you need to know, metals get oxidized, non-metals get reduced. Not bad, right? Not bad. Okay. Let's get the homework. No, we already did 3 and 4. It's going to be 5 and 6. Really great if I hold my packets. It's going to be 5 and 6. 5 and 6. And we're going to switch over to the document camera. And I'm going to work some of these out with y'all. 5 and 6.
That was not blood.
So the first part is going to be easy because y'all have already done. The mixed view is not that bad. I need a packet. I'm just gonna. I'll let y'all work a little bit.
Is there a homework video?
I was gonna work it on the document camera. Is that all right? Number 2. Okay, I'm gonna switch it over to document camera then. And I'm gonna end this and do pause. Yes. 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 I know. No, don't do that. Okay, I was gonna work them on the document camera. Okay. Okay, so here we go. This is our homework. I'm gonna start. This is page 5. I need to pull this up so y'all can see what I'm doing. Get out of here.
Turn your mic down.
Oh, are we ending the meeting?
Yes, I'm just moving it over to our screen share here.
All right, bye-bye.
You're all done?
I paid attention to every word you said. Metals
Here,
get oxidized,
there
non-metals get reduced.
I'm gonna pull this down so y'all can see. Okay. All right, now let's. Kaden, you're always the one who can tell me if you can see. That is. Is he gone? Okay. Oh, Kaden, what are you doing over there? No, I said I was gonna do it on document camera. Y'all see?
Yeah.
Is it too far away?
How come in super hot you can't catch bullets?
Can you see that?
They're balls. They'll pierce you.
Gina?
Okay, so
I really want to play.
it says, what are the two products of this reaction? What are my products? Where are my products? Is it these ones or is it these ones? Which ones are the products? Yeah, so it's these, right? These are my products. I'm not gonna make you rewrite it. Question. You just got here. Go quick. All right, so on this review here, we also have, it says if 191 grams of NaCl reacts with 74 grams of calcium, what is the mass of calcium chloride produced? Okay, so how do we solve this? Is this really complicated or can we do this? We just add, yeah. Yeah, so we're gonna say 191, okay, plus 74.
Oh, Jason, I thought of a funny joke. I thought of a funny meme.
Okay, 191 plus 74,
So
that equals 265.
it's SpongeBob SquarePants, and it's the Grandma's Kisses episode. And the scene where Patrick is enjoying some cookies, and SpongeBob says to Patrick,
I don't know if he doesn't know if he's talking. So we got 265 is equal to the other side. We got 80 plus something. So all you have to do is subtract 265 minus 80. That's 185. Yes, I will do number 4, and then I'm gonna have y'all take a minute and like work a few on your own. I will do number 4. It says in the balance reaction shown above, what is the ratio of coefficients? So all you have to do on number 4 is balance it. Okay, you need to balance it, and then whatever the big numbers are, once it's balanced, is this already balanced? Let's check. How many F's do we have on the left side? How many F's do we have on the right? Okay. How many RBs do we have on the left side? How many do we have on the right? How many chlorines do we have on the left side? 2, yeah. They go to everything. And then we got 2 over here, right? So this is just missing the 1s in the front. So the answer is going to be 1 to 2 to 1 to 2. So choice B. Okay. I'm going to give y'all a couple of minutes to work on your own. And then I will do some like, in like a few more minutes, I'll do a combustion reaction for you. So I'm going to give you like 5 minutes to work on your own. Okay. I have too many. I'm in the bathroom right now. Once somebody comes back, then you can go. Okay, and that's okay.
Oh my goodness.
Oh, okay, go ahead.
See, that's what you're here.
See, don't worry. I'm a hog blank packet. And I already filled out mine. Okay, so maybe.
I fell asleep, my bad.
Here,
Maybe next time.
let me see your packet for a second. I'm gonna
Mine?
pull you up on the document camera.
Mine?
Mhm.
Why not?
Because mine's already filled out all the way.